What is a subnet mask? So that is the topic of this video. Now before we talk about what a subnet mask is, we must first talk about what an IP address is. An IP address is an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. And to be specific, I'm talking about an IP version 4 address. An IP version 4 address is a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is from 0 to 255. An IP address consists of 2 parts. The first part is the network address, and the second part is the host address. The network address or network ID is a number that's assigned to a network. So every network will have a unique address. The host address or host ID is what's assigned to hosts within that network, such as computers, servers, tablets, routers, and so on. So every host will have a unique host address. Now, the way to tell which portion of the IP address is the network or the host is where the subnet mask comes in. A subnet mask is a number that resembles an IP address, and it reveals how many bits in the IP address are used for the network by masking the network portion of the IP address. Now, in the world of computers and networks, IP addresses and subnet masks in this decimal format here are meaningless. And this is because computers and networks don't read them in this format. And that's because they only understand numbers in a binary format, which are ones and zeros. And these are called bits. So the binary number for this IP address is this number here. And the binary number for this subnet mask is this number. And these are the numbers that computers and networks only understand. So the next question is, how do we get these binary numbers from this IP address and this subnet mask? So here we have an 8-bit octet chart. The bits in each octet are represented by a number. So starting from the right, the first bit has a value of 1, and then the number doubles with each step. So there's 2, then 4, 8, and so on, all the way up to 128. Each bit in the octet can be either a 1 or a 0. If the number is a 1, then the number that it represents counts. If the number is a 0, then the number that it represents does not count. So by manipulating the 1s and 0s in the octet, you can come up with a number range from 0 to 255. So for example, the first octet in this IP address is 192. So how do we get a binary number out of 192? First, you look at the octet chart, and then you will put 1s under the numbers that would add up to the total of 192. So you would put a 1 in the 128 slot, and then a 1 in the 64 slot. So now if we count all the numbers that we have 1s underneath them, you would get a total of 192. All of the other bits would be zeros, because we don't need to count them since we already have our number. So this number here is the binary bit version of 192. So let's do the next octet, which is 168. So let's put a 1 under 128, 32, and 8. And then all the rest would be zeros. So if we were to add all the numbers that we have 1s underneath them, we would get a total of 168. The next octet is 1, so we'll put a 1 in the 1 slot, and when you add up only 1, you get 1. And the last octet is 0, which makes things simple because all the binary numbers would be all zeros. So here is the binary number for our IP address. Now the subnet mask binary conversion is exactly the same way. So in this subnet mask, the first 3 octets are 255. So if we were to look at this subnet mask in binary form, the first 3 octets would be all 1s, because when you count all the numbers in an octet, it will equal 255. And then the last octet would be all zeros. So here we have our IP address and subnet mask in binary form lined up together. So the way to tell which portion of this IP address is the network part is when the subnet mask binary digit is a 1, it will indicate the position of the IP address that defines the network. So we'll cross out all the digits in the IP address that line up with the ones in the subnet mask. And when you do this, it will reveal that the first 3 octets of the IP address is the network portion, and the remaining is the host portion. So the ones in the subnet mask indicate the network address, and the zeros indicate the host addresses. So in another example, let's use a different IP address and subnet mask, and let's put them in binary form. So in this example, the first 2 octets are 255, and the last 2 octets are 0. So if we cross out all the digits in the IP address that line up with the ones in the subnet mask, we'll see that the first 2 octets is the network portion, and the last 2 octets is the host portion. And let's do one more. And in this subnet mask, the first octet is 255, and the rest are zeros. And then we'll cross out all the digits again, and this time it reveals that the first octet is the network portion, and the last 3 octets are for hosts. Now, figuring out the network and host parts of an IP address using these default subnet masks was simple, because as I stated before, when you count all the numbers in an octet, it will equal 255. So we automatically know that the numbers in the octet are all ones. So we really didn't have to see the IP address or subnet mask in its binary format because it's so simple. But what if the subnet mask was this number here, where the first 2 octets are 255, but the third octet is 224? So this is a little trickier. So here is the binary number for this subnet mask. The first 2 octets are all ones, and in the third octet, the first 3 bits are ones, which will equal 224, because starting from the left, when you add the first 3 bits in an octet, it adds up to 224. So let's put this subnet mask and IP address in its binary format. And again, if we cross out all the digits in the IP address that line up with the ones in the subnet mask, we'll see that in the IP address, the first 2 octets and the first 3 bits in the third octet is the network part, and the 13 remaining bits are used for hosts. So another question is, why does an IP address have a network and a host part? Why can't it just have a host part to uniquely assign each device an IP address? So why does it have a network part also? Now, the reason for this is manageability. It's for breaking down a large network into smaller networks or subnetworks, which is known as subnetting. So for example, let's say that there were no small networks. Let's say that an organization has a large amount of computers in one huge network. Now, when a computer wants to talk to another computer, it needs to know how and where to reach that computer. And it does this by using a broadcast. A broadcast is when a computer sends out data to all computers on a network so it can locate and talk to a certain computer. So for example, let's say that this computer here wanted to communicate with this computer over here. So what happens next is that this computer here will send out a broadcast out on the network asking the target computer to identify itself so it can communicate with it. But the problem with this is that every computer on this network will also receive the broadcast because they are all on the same network. So as you can imagine, if every computer on this large network was broadcasting to every other computer just to communicate, it would be chaos. It would slow down the network and potentially bring it to a halt because of the tremendous amount of broadcast traffic it would cause. And it might even cause fires. Well, not really, but... And if a problem were to happen on the network, it would be very difficult to pinpoint because the network is so big. So in order to prevent this, networks need to be broken down into smaller networks. And networks are broken down and physically separated by using routers. And by using routers, this would alleviate the problem of excessive traffic because broadcasts do not go past routers. Broadcasts only stay within a network. So now, instead of one large network, this network is broken down into 6 subnetworks or subnets. So now, if this computer here wanted to communicate with this computer over here, the computer will send out a broadcast that only the computers in its subnetwork can receive. But since the target computer is on a different subnetwork here, the data will be sent to the default gateway, which is the router, and then the router will intelligently route the data to the destination. So this is why IP addresses have a network portion and a host portion. So networks can be logically broken down into smaller networks, which is known as subnetting. Hey guys, I just want to break in here and tell you that if you're a beginner and you want to learn more about networking, I highly recommend an audiobook that will help you do that. I linked it in the description below and you can download and listen to it for free. Just get the book by signing up for the free 30-day trial of Amazon Audible Premium Plus. But even if you cancel your Audible membership at any time during the 30 days, the audiobook is still yours to keep forever without paying anything. So just click the Amazon affiliate link below, and by doing that you'll also be supporting my channel because I still get commission even if you decide to cancel. So once again, it's completely free and thank you. So let's do an example here. So let's say that you have a small business and that this is your IP address and subnet mask. Now let's say that your small business has a total of 12 computers and all 12 of these computers are on a single network. And these computers belong to different departments indicated by their colors. But let's say that you wanted to separate the computers into 3 different networks so that each department won't see the other department's network traffic. So instead of having one network in your business, you want to break it down into 3 small networks. So the way to break this network down into smaller networks is by subnetting. Subnetting is done by changing the default subnet mask by borrowing some of the bits that were designated for hosts and using them to create subnets. So in this subnet mask, we're going to change some of the zeros in the host portion into ones so we can create more networks. So if we leave the subnet mask the way it is, it will give us one network with 256 hosts. Now technically we have to subtract 2 hosts because the values that are all ones and zeros are reserved for the broadcast and network address respectively. So we actually have 254 usable hosts. But we need to change this subnet mask so we can produce the 3 networks that we need. So for example, let's borrow 1 bit from the host portion. So here is our new subnet mask. So now the 4th octet is 128 because when you count the first bit in an octet, it equals 128. So by borrowing 1 bit, this will divide the network in half. So now, instead of having one network with 254 hosts, this will give us 2 networks or subnets with 126 hosts in each subnet. Now let's keep going and borrow another bit from the host portion. So now we are borrowing a total of 2 bits from the host portion. So here is our new subnet mask, and the 4th octet is 192. So by borrowing 2 bits, this will divide the network even further, and now it'll give us 4 subnets with 62 hosts each. And again, let's borrow another bit from the host portion. So here is our new subnet mask, and by borrowing 3 bits, this will divide the network into 8 subnets with 30 hosts each. So if we continue breaking down this network, here is the result if we borrow 4 bits, which will give us 16 subnets with 14 hosts each. And here is the result if we borrow 5 bits, which will give us 32 subnets with 6 hosts each. And if we borrow 6 bits, this will give us 64 subnets with 2 hosts in each subnet. Now this is pretty much the limit because if we borrow 7 bits, it will give us 128 subnets but with 0 usable hosts. So as you can see, the more bits the network portion borrows from the host portion, the amount of networks that can be created doubles with each bit, but also the amount of hosts per network gets cut in half with each bit. So going back to our business example, if we wanted to break this network down into 3 smaller networks or subnets, we would have to borrow 2 bits from the host portion. So even though we only need 3 networks, this subnet mask will give us at least 4 networks to work with. So our new custom subnet mask for our 3 subnets would be 255.255.255.192. So now our network is broken down into 3 smaller networks or subnets. Now, just to be clear, this video is about subnet masks. This is not a full lesson on subnetting, because there's a little more to subnetting than what I showed you here. I'm just showing you how subnet masks relate to subnetting. Now, IP addresses and subnet masks come in 5 different classes, which are classes A through E. However, 3 of these classes are for commercial use. So here is a chart of the IP addresses and default subnet masks, which are class A, B, and C. And you can tell by the number in the first octet of the IP address and by the default subnet mask which class they belong to. Now, when an organization needs networking, they will need an IP address class according to the needs of that organization, which is based on how many hosts they have. So if an organization has a very large amount of hosts, they will need a Class A IP address. A Class A IP address can produce up to 16 million hosts. So as you can see, in a default Class A subnet mask, the host part is very large. 3 octets are used for hosts, which is why it can produce so many. An example of an organization that would need this many hosts would be something like an internet service provider, because they would need to distribute millions of IP addresses to all their customers. A Class B IP address can produce up to 65,000 hosts. This class is given to medium to large organizations. And a Class C IP address can produce 254 hosts. Class C IP addresses are used in small organizations and homes that don't have a lot of hosts. Now, subnet masks can also be expressed in a different method called CIDR. And CIDR stands for classless interdomain routing, which is also known as slash notation. Slash notation is a shorter way to write a subnet mask, and it does this by writing a // and then a number counting the ones in the subnet mask. So for example, if you see an IP address like this with a CIDR notation of /24, this means that the subnet mask is 24 bits in length, meaning it has 24 ones. If the CIDR notation is /25, this means that the subnet mask is 25 bits in length. Or if it's /26, this means that the subnet mask is 26 bits in length. Or if the CIDR notation is /8, this means that the subnet mask is 8 bits in length. So I want to thank you all for watching this video on subnet masks. Don't forget to subscribe and get the audiobook for free using the link below. And I'll see you in the next video.